Okay, so we'll be doing some hands-on today on the disk groups, looking into the disk group attributes, and to be precise, this is going to be the agenda for part 1, uh, which is actually part 1 video of uh, our ASM series 3. So I'm going to talk about how to create a ASM disk group. I'm going to talk about the disk group attributes, an important discussion. I'm also going to talk about the compatibility attributes. What is the change because of those compatibility attributes, and what are the different values supported, and when what should be used. Then I am also going to talk about features enabled by disk group compatibility attributes, another important discussion. You need not remember this. You can always refer the compatibility chart to find out what is available because of setting this compatible value to 10.2 and what is unavailable because of this. Similar way, what if I set the compatibility attribute to 11.2, and what are those different compatibility attributes? I told you there are 3 of them: compatible.rdbms, compatible.asm, and compatible.advm. So it's going to be an interesting discussion on that. To get started off with, I'm planning to create a disk group. And I'm going to do this disk group creation using 3 different administrative utilities. There is a fourth one also, as I said, DB console, but I'm not going to show it via DB console because not in every implementation that you are going to get a DB console. It's a web interface. Like for database, you use the DB console for web-based administration of your database. The same DB console is extended for ASM purpose as well. So you can use the same web interface for doing the ASM administration. So basically all the admin activities that could have been otherwise performed using ASMCA, SQL Star Plus, or ASMCMD can also be performed using the other complementary tool, DB console. Remember, DB console requires you separate licensing. So even if you have procured an enterprise edition of Oracle, doesn't mean that DB console is licensed along with it. It comes with it, but it needs to be licensed separately. So first things first, let's try to create a disk group. I'm going to quickly run you over the understanding of a disk group. So your database will store files onto disk group. Here there are 2 disk groups depicted, disk group A and disk group B, with different sizes, with the disks of variable nature, like count wise. I have 4 disks in disk group A. So if one of my database stores a file on ASM disk group A, the file is going to be striped across all the participating disks in a disk group. The logic of how the file is striped, we already talked in our earlier discussion. So I said there is something called as data extent. The data extent is of the size of 1 AU for the first 20,000 extent. Then it is of 8 AUs for the remaining 20,000 extent, and beyond that then it is of 64 AUs. By default, the AU size, if not selected at the time of ASM disk group creation, it would by default be 1 MB. But if you think that 1 MB, uh, it's normally that 1 MB has been derived looking at the normal operating system's way of doing an IO. The maximum IO buffer used for any IO is 1 MB, and that's why those 1 MB extents are created, or allocation units are created. But nowadays the storages are getting intelligent. They provide you faster IO throughput. So which means you may be able to tune it beyond 1 MB. That's why Oracle also allows you to select an allocation unit size at the time of disk group creation, which could be more than 1 MB. That's what we are going to see today. So whatever you store on a disk group gets striped across all the participating disks in a disk group, or across all the participating disks within a failure group, and those contents would be made redundant across some other failure group which is part of the same disk group configuration. I'm going to use first ASMCA GUI method, and from ASMCA I'm launching VNC. I'm connected to the machine alpha. Here I am, and I'm switching myself as Oracle. Last time I created two env files. One of them was grid env. Now you can see ASMCA utility comes from the grid home bin directory. I'm launching it. It's a GUI tool. We'll quickly review what is the current configuration like. So I'm jumping on the tab ASM instances, and quickly you can see here on node alpha there runs an instance ASM1, and on beta there is an instance called as ASM2. Both of them reportedly showing status as up, and both the instances have ADVM driver loaded. I will talk in another session what is ADVM. I can see from here which are the connected clients for this instance, and I can see the database instance that is currently connected to this is RACDB1. Equivalent is LSCT. So whatever LSCT shows from the command prompt there is what you are seeing here, and the equivalent SQL star plus way of doing this is to query $ASM client. Other options available to you here are start and stop, which are currently disabled because of we being on grid infrastructure, and I am currently connected to that node. But the moment I select the other node and the ASM instance, I get to see stop instance. So I can either stop it from ASMCA. I can also say from SQL star plus shutdown immediate, or I could have used shutdown command from here as well, ASMCMD shutdown. So multiple ways of doing the same things. I'm jumping onto the disk groups tab. From here I can see the name of the disk group that I have as of now is data, is made up of two LUNs of 3 GB each. So the total raw capacity is 6 GB. Since redundancy is external, usable size is also 6 GB, out of which 4 GB is currently free. The disk group is mounted on 2 of 2 indicates that at least there are 2 ASM instances who have currently this disk group mounted on them. Once I right click on this, I can see view serviced databases. This will show me which databases and other client utilities have stored files on this particular disk group. So I can see RACDB, where the database runs instances runs on alpha and beta respectively, having instance name as db1 and RACDB2, has their database of 1.58 GB, and the database itself runs from this particular Oracle home. Apart from this, cluster with the name group 00 has 0.26 GB of its files stored onto my disk group, OCR and voting disk. Apart from that, you also have an ASM SP file. So this is what is currently there onto that disk group. I can see the disk group status. It says mounted 2 of 2. You can find out where it is mounted. So it's mounted on ASM instance 1 on alpha, ASM instance 2 on beta. I can add disks to this disk group. I can remove a disk from a disk group. I can change attributes of a disk group. I'm clicking on edit attributes. Very few of them can be changed, including compatibility. So there's a discussion coming on the compatibility and disk group attribute. More on this at a later stage. I can create templates. I would also be talking today about what is a template and what is the significance of it. I can create ACFS for database home. More on this in a later discussion. I can mount it or dismount it from the local node. I can drop that disk group. I can dismount it from all the nodes. So these are some of the supported activities from ASMCA with respect to a disk group. As of now, I do not have any ASM volumes, so that's why this tab is blank. Since I do not have a volume, there is no point going on to the other tab. The other tab only comes in picture once you have volumes. So there is no ASM cluster file system as well because I do not have volumes. First thing, I am going to create a new disk group. So I say from here create. It says what type of a disk group you want to create. I am saying the name of the disk group is DG norm of normal redundancy. Then normal redundancy requires you to have at least two failure groups defined. So I am saying show all the eligible disks only. So it's only listing provision disks. Remember, a provisioned or a candidate disk is a freshly provisioned disk available for ASM operation. If I however click on this one, I see the two unwanted ones as well, which are currently member of the disk group data. So I am not saying show all, and there's a short name associated with each one of them and the failure group to which they belong to. So I am saying show eligible, and I am selecting two disks. Short name I am assigning them. This is for my own understanding. D3, D4. Remember, it's not mandatory. And the failure groups that I am trying to name them as FG1 and FG2. I can say show advanced properties, and for some reason I am selecting compatibility attribute for all of them as 11.2.0, which is the highest value for compatibility until 11G release 2. If you select compatibility to 11.2.0 for RDBMS, for ASM and for ADVM, that means all the ASM features built till date are available to you. If the compatibility value is lower, then all the features that are there in 11.2.0, you may not be able to use all of those features. More on it at a later stage. I said if you do not select allocation unit, the allocation unit defaults to 1 MB. The selectable sizes, the options available to you are 1 MB, 2 MB, 4 MB, 8 MB, 16 MB, 32 MB and 64 MB. So these are the sizes of AUs. I am going to keep it at default and hide these advanced options. Once done, so automatically it has detected my disk. Remember, these are ASM provisioned, ASM lib provisioned disk. That's why the search pattern shows ORCL colon. Remember, during the initora parameter discussion, I explained you one parameter called as ASM underscore disk string, which tells you operating system dependent paths where probable candidate or provision disk can be located. And for ASM lib, I said that path is ORCL colon star. So which indicates these disks are provisioned via ASM lib. If you are unable to find your disk from here, you can always go and change the disk discovery path, which is nothing but value for your ASM underscore disk string parameter. Once done, I click OK. So now it's building my disk group. It's building, taking those two disks, ASM disk 3 and 4, each one of which is 3 GB, and it's building me a normal redundancy disk group. So raw capacity of my disk group is 6 GB, but usable capacity is only 3 GB. As of now, I can see only the disk group data is listed in CRSCTL status output. I am saying ASMCMD LSDG. So the disk group is still being created. I told you earlier this operation is somewhat slow in our environment because the LUNs that we see are coming on a regular copper wire using ASCII protocol. In a real world, it wouldn't have taken this long because all of them would have been a fiber channel LUNs connected via HBS. Remember, we are not even using HBS, we are using regular NICs with ASCII initiator software to see those ASCII LUNs using a regular 100 Mbps copper wire. So this operation is frustratingly slow in our environment, and so is any operation that talks on or that stores or retrieves data from a disk group. What I don't like to see on any machine is this particular highlighted item, which indicates an IO weight. In a real world, this IO weight should be 10% or below. Which in our case is quite high. Higher the IO weight, it indicates that there is a bottleneck on the storage side. So either the path that links your machine to the storage is not the fastest available path, or probably the storage is giving you disks which are hotspot disks. So those disks are hot in nature probably. So try to eliminate everything that comes from that disk or that disk frame. As of now, I can see the disk group DG norm is created, and I can see it's mounted on 2 of 2. I run through the same command that I ran earlier. You can see now the disk group DG norm is now available. So the raw capacity is 6 GB, and that entire 6 GB is free, but the usable is only half of it. So whatever goes now on this disk group going forward would all be mirrored until I categorically mark as an exception. So everything that goes now on this disk group will be written twice, because the disk group's redundancy factor says it's normally redundant. So see here, while the previous one is externally redundant. The voting files column shows you whether yes or no for a given disk group if it hosts the voting files, the voting disk. So I can see for DG norm the voting disk does not reside on this disk group. However, it's there onto the disk group data. So I can see my voting disk is on to data, not on DG norm. Another way to find out things about disk group is to issue a command from $ASM underscore disk group. You can see there's another disk group. Now I can categorically see here the database compatibility for the disk group data is 10.1, while the newly created one where I mentioned that for all compatibilities I need the value as 11.2.0. So I can see compatibility is 11.2.0 and database compatibility is also 11.2.0. If I go to create disk group again, I don't see any empty disks available now. If I report them, all of them are reportedly showing as member disks. You can find out more information about this by querying select star from $asm underscore disk, and all of them are reportedly showing as member. The short names for these two disks I have given as D3 and D4, while for the previous one, since I didn't categorically mark their names, they defaulted to whatever name they are using currently, ASM disk 1 and ASM disk 2. So all of them are reportedly showing as status as member. Now when you connect to ASM, you can drop a disk group. So I'm going to drop it from here in the front end. I don't need it, so I can drop that particular disk group. It says, do you really want to drop the disk group? To which if I say yes, it has dropped it now. So that disk group is now removed. I am using the same select star from $asm disk group command now. I don't see that disk group any longer. If I go to and say create, see the status of those disks is now reportedly showing as former. Remember we discussed the status as provisioned, candidate, former, member and foreign. So that disk group is no longer to be seen. That's what I wanted to show from ASMCA. This time we are going to redo the whole operation again, however using SQL Star Plus. You can create a disk group from SQL Star Plus as well using something like this. Create disk group name, type of redundancy that you are expecting, followed by the disk definition. If you want to issue a short name, then provide the name attribute. There is no need for you to mention size. If the size can be detected at a OS level itself, there's no need. And mention then, so I can see here the disk that I want to add is first disk, which will be part of some disk group, FRA to be precise here, and the other disk. You can also assign some short names to those disks. So I am going to recreate this particular disk group using the create command. In my case, those disks are ASM disk 3 and ASM disk 4. You could have given the failure group options as well, or you can leave it blank. Oracle would anyways assign the failure group name. So using this method, you could have also assigned a explicit fail group name. If you don't give the fail group name, Oracle would anyways assign some failure group name. If you want to give your own failure group name FG1, FG2 like this, you can always put it here. I'm going to keep it simple, something like this. So I said create disk group, say dgnorm, normal redundancy, and the disk that I want. If you want, you can additionally add fail group clause. Last time while doing it through ASMCA, I categorically marked the fail groups as FG1 and FG2. Here I am not putting it explicitly. I am connected as sysdba. If you see, sysdba is not a highly privileged account in case of ASM. So anything that requires high privileges, you must connect in as sysasm. If I type the same command here, it's at least working. There's another way of creating a disk group, that is using ASM CMD, which is a ASM command line utility for creating a disk group. However, I need to wait until this one finishes. So the disk group got created now. Again, I could say ASM CMD LSDG. You can see that the disk group is created again. If not required, you can always drop it. Remember, dropping a disk group is a destructive operation, and that's why you must be connected as sys ASM. I can say drop disk group. Prior to dropping it, I would like to see if it is mounted on both the instances. If it is mounted on both the instances, you won't be able to drop it using SQL Plus. It will complain that a disk group cannot be dropped because it's mounted on some remote instance as well. So a couple of things before you start dropping a disk group. Number one, so to be able to drop a disk group, number one, it should be mounted. You cannot drop a disk group which is in a dismounted status just like that. You will have to, it is still possible, but using a force option. So to be able to drop a disk group, the disk group must be mounted, and it must be mounted exclusively by the current ASM instance only. If it is mounted by some other remote ASM instance, you won't be able to drop it. So I launched this one, and I can see it's currently mounted on only one. I can say mount on all nodes. So the other instance would also try to mount that disk group. And once it is mounted, I cannot drop it. I cannot say drop disk group name, including contents, which is optional. So you can see now it's mounted on beta as well. You can see here it's mounted on 2 of 2. Now given this case, if you try to drop it, I am saying drop disk group DG norm including contents. It complains disk group not dropped. Disk group DG norm is mounted by another ASM instance. So I must dismount it from there. So now it's dismounted from the other one. I am on beta here. So it's shown as dismounted. Once it is dismounted, now you can attempt a drop operation. See here. Once I say drop disk group DG norm including contents, now it allows you to drop that particular disk group. Next one is to create the same disk group. This time, however, using ASMCA. For this one, you need to create an XML format command, something of this fashion. And here you would have to mention the name of the disk group. So if you see how this command is formed, so read it like this indented file. So we are trying to create a disk group named data or whatsoever, say DG norm, with redundancy style as normal, with the failure group FG1 with whatsoever disk you want to put into it, with failure group FG2 with whatsoever disk you want to put into that as well, followed by the disk definition. So the disk definition is with whatever compatibility attributes you want to mention, and then this has to be passed to ASM CMD. ASM CMD allows you a command which helps you create a disk group. See here mkdg. So you can say mkdg help, or rather help mkdg. I am reading out through the help of make disk group. Creates a disk group based on the XML file configuration. Either say mkdg followed by here document, uh, not here document, directly followed by the XML file path. If not, directly give the tags to mkdg. I am going to directly give it to mkdg here itself, something like this. Directly put in those settings here. I am going to bring them all on a single line for readability, for manageability purpose rather. So now it's all on single line. Put it by saying mkdg in single quote, the whole thing. If all goes well, it should allow us to create a disk group. So the disk group has been created. I am using lsdg command to list out. If it is not mounted by the second instance, you can always manually mount it. When I say slash, it says it's not mounted. I am on to beta. I can always manually mount it by saying alter disk group name, mount. After which you can query the status again. Once this is done, I am going to drop the disk group and reuse those two disks, ASM disk 3 and 4. Then we'll see another operation, how to add a new disk to an existing disk group. This is all about creating and dropping a disk group, or mounting and dismounting a disk group. The next operation is to see how to use a single disk and add it as part of some existing disk group, which will automatically trigger the rebalancing operation. On the similar lines, we will try to drop a disk from a disk group, and we will also see the nuances, like which one is a better option when it comes to adding and removing a disk, how to stop multiple rebalancing operation to be triggered when adding multiple disks or while adding and removing a couple of disks. So you can see now the disk group is again mounted. Once done, I can dismount a disk group because I am planning to drop it now. So it's dismounted from beta. Once it is dismounted from beta, I can attempt a drop operation. You can see here there's a command for dropping a disk group. So you need to say drop dg -r is for recursive, which is like including contents, -f for a forceful drop, only applicable if the disk group cannot be mounted. I told you the two prereqs to be able to drop a disk group. It must be mounted exclusively on the current instance only. If it's a rack environment, then it must be only mounted on the current instance. And you must be connected as CCSM. Now consider a case that I had a disk group named dgbad of external redundancy with 4 disks. So how many disks must be accessible to be able to mount this disk group? How many disks must be accessible to mount that disk group? All 4. If any single disk is missing, I won't be able to mount it. Remember, the redundancy is external. Now consider a case that one of the 4 disks is inaccessible. Can I mount it? Can I drop it? Because dropping requires the disk group to be mounted, and I cannot mount it because one of the disk has failed. How to remove such disk groups? In such cases, even when the disk group cannot be mounted, you can still force remove a disk group. So I am trying to remove the disk group dg norm. So it's, I said drop dg -r -f dg norm. It says disk group does not requires the force option because anyways it's there. So I said drop dg -r dg norm. Now it doesn't complain about that force option here. Now the disk group is removed. Now again ASM disk 3 and 4 are free, which I can add to my existing disk group data. I said lsdg, you can say lsdsk, I said list all the disks that are currently part of my disk group data and also show the disk usage -k option. So I said lsdsk -g data -k. It says there are only 2 disks that are currently part of your externally redundant disk group data, ASM disk 1 and 2. Now I want to add one disk to this particular disk group. So I am saying I am logging into SQL Plus. Remember, the moment I add a disk to a disk group, that would change the geometry configuration of that particular disk group, which would automatically trigger a rebalance operation. Prior to running it, I am checking, is there any long running operation going on? No. I am checking using ASMCA just to make myself doubly sure. Currently, So whatever you can see from $ASM operation, you can also check it from the ASM CMD command LSOP. So I don't see any long running operation because there is no rebalancing happening as of now. Now I want to add a new disk to my disk group. I said alter disk group data, add disk ORCL colon ASM disk 3. This would automatically trigger rebalance. Now I am checking what's the status on rebalancing. See here, rebalancing is going on now. So whatever data is not there on the newly added disk, it will try to pick up the data extents from the existing disk 1 and 2, and it will try to then equitably distribute it amongst all the participating disks to avoid a hot, a warm and a cold disk situation. So all of them should experience a balanced IO. I am checking using ASM CMD LSOP and I can see that the rebalancing is running. This view is technically synonymous to $session long ops, which you query on the database side to check the progress of long running database operations. Long running database operations, for example, are create index, gather statistics on a table, on a schema, on a database, or RMAN backups. So these are all reportedly long running operations. Basically any operation that hits the high watermark of a segment is called as a long running operation. So it is technically synonymous to $session long ops on the database side, $ASM operation. Now I told you earlier, it's frustratingly slow in our environment. It has to migrate a total of 674 units from existing disk to the new disk, and so far it has only done 31. So it's migrating the AU's data extents from existing disk to the newly added disk, and by the time this happens, I'm going to add another disk, the fourth disk. Again it will trigger the rebalance operation. There's no point waiting for this rebalance operation to finish. I can see now a considerable progress. From 31 it has jumped to so far 118 out of 676 units of work. Now consider a case that I have a disk group, say DG data, where I have 4 disks already present, where two disks are of 80 GB and 2 disks are of 40 GB. Rather, let's say 3 and 1. This is my current disk group configuration, let's say. So I have a disk group DG data with 4 disks. 3 disks are of 80 GB each. 1 disk is 40 GB. Now I want to do this. Remove a 40 GB disk and instead add a new 80 GB disk, so that all disks become 80 GB. Now question is, what should I do first? Adding a new 80 GB disk or removing a 40 GB disk and then adding a 80 GB disk? So there are two options. Method 1, add a 80 GB disk and then remove the 40 GB disk. Method 2, remove a 40 GB disk and then add the 80 GB disk. Just to give you a couple of more options, this disk group is with external redundancy. Which option is better? Method 1, add a 80 GB disk and then remove the 40 GB one, or add remove the 40 GB disk first and later add a 80 GB disk. Which option seems better? You need to be at least faster while answering than the rebalancing. It shouldn't so happen that the rebalancing of the disk has finished by ARBN single process and 16 people in the class couldn't answer a simple question. So try to beat the ARBN's rebalancing at least. So which method you think is a better alternative and why? So better you add a disk and say that not to do rebalancing and later remove the disk of 40 GB. It will anyways trigger the rebalancing only once. Or even the better option would be add and remove in a single command. So this will anyways trigger the rebalancing activity only once. I am checking on the progress of rebalancing. It's about to finish. Now I am going to swap the disk. Our disk group has ASM disk 1, 2 and 3. 4 is not a member. So I am going to swap disk 3 with disk 4, but triggering rebalancing only once, using basically add and drop in the same command. Basically we are swapping between 4 and 3. 4 who is a non-member, 3 who is a member. We are doing a reverse of it now. We are getting 3 out and pushing a 4 disk 4 in instead of disk 3. The rebalancing has finished. So now I don't see any long running operations. The same I can confirm using LSOP. So next thing is, what if I want to replace a disk, existing disk, let's say ASM disk 3, with a new disk that I want to add, ASM disk 4. Instead of triggering it as two separate operations, you can write it in a single command. This is to avoid an unnecessary rebalancing operation that will get triggered once for adding a disk and another for removing a disk. For previously syntax error, it suggests ASMCMD LSDSK -G data, although I can see it as part of the disk group configuration. So I'm planning to add the disk and remove it in all in one single go. I'm checking the disk status from $ASM disk, and reportedly group 3 is currently member, group ASM disk 2 is currently a member, ASM disk 1 is member, and ASM disk 4 is former. So I want to swap disk 4 with disk 3, making this disk 4 as a member and ultimately removing disk 3 from the existing disk configuration. For this I am issuing a command to do it in all in a single go. Alter disk group data, add disk orcl colon ASM disk 4 and drop disk ASM disk 3. So instead of two rebalancing operation, it would trigger the rebalance only once, avoiding those unnecessary IO. In the case if you would have selected add disk as one operation and remove disk as another. Now this would have automatically triggered the rebalancing operation. I am querying it by saying lsop or from select star from $ASM underscore operation. Now it's going to take again a long while to finish this operation, but at the end of it, disk 3 will be showing status as former and disk 4 will instead show a status as member. So we added and removed the disk in one shot here. Alter disk group data, add disk 4 and dropping the disk 3. Earlier disk 3 was a member, disk 2 was a member, disk 1 was a member, disk 4 was former. So now we want to see disk 4 should be a member and disk 3 should report the status as former. The rebalancing also has finished. So disk 3 is now showing status as former and disk 4 is showing status as member. So we swap the disk using a single operation to avoid an unnecessary rebalancing. The next one is about disk group attributes, and I am going to talk about a couple of them. You can query them using $ASM underscore attribute dynamic performance view, and quite a few of them are there. So these many are the disk group attributes. I am going to talk about the one those are mentioned at the top, especially disk repair time, AU size, sector size, compatible, so on. The first one is the disk repair time. This one, it specifies the amount of time ASM will wait from when a disk goes offline until ASM drops it and rebalances the disk group. The valid values are between 0 to 136 years and the default value is 3.6 hours. So consider a case that I had a disk group Obviously this only applies for disk groups with some redundancy style, either normal or high. It doesn't apply for external redundancy. So it tells you the tolerance until which ASM would wait for a disk group. Let's say I had a disk group called as DG data with normal redundancy having 16 disks spread across two failure groups. FG1 was having 8 disks and FG2 is having, let's say, again 8 disks. So question is, what would happen if one of the disk is reportedly missing offline? So one of the LUN is not visible. Since I am talking about a disk group with some redundancy other than external, my disk group can still be operational if one of the disk is offline, because we are having redundant writes across the other failure groups. So while accessing the data, there isn't any problem as such. So question is, what happens when a disk goes offline? The default value for the attribute disk repair time is 3.6 hours, which means ASM doesn't do anything for 3.6 hours. It will just wait for that disk to be available again. If within that time the disk doesn't comes online, then it will start doing the salvaging of data. So it will consider that disk as a permanent fatal error, and then it will try to recover the data from the disk by referring to the other failure group. So it will compare the other failure group. It will check the failure group from where the disk has failed. So I am assuming disk 3 is reportedly offline for 4 hours now. So in this case, we need to salvage the data on disk 3. So Oracle would refer to remaining 7 disks, will compare the data on those 7 disks against the data which is available on the other failure group, and then it will try to reconstruct the data in FG1 considering disk 3 as a fatal failure. But how sooner or later? Not until the expiry of that 3.6 hours. So it will wait for those 3.6 hours for that disk to come online. If that doesn't happens by then it will start the salvaging procedure. I told you earlier, it's not hard and fast that you need to have same number of disks across failure groups. You may have different configuration across failure groups. So what would happen going forward? As long as there is enough space available amongst the remaining 7 disks in failure group 1 and the other disks in failure group 2, all 8 disks, it will try to replicate the contents as long as it can be honored. The moment it cannot be honored, it will error you out saying no new file can be stored here. So how long it would wait? It will wait for until the expiry of 3.6 hours, and longest it can wait is 136 years. When the disk has disappeared, it will do no action. Next is AU size. I have described this. While creating a disk group, you can select a customized AU size. If you don't, the default value is 1 MB. The allowable values for AU size are 1 MB, 2 MB, 4 MB, 8 MB, 16, 32 and 64 MB of AUs can be selected from. Default is 1 M. So you can see here the default size of AU is 1 MB. The next one is sector size, 512 bytes of a sector. When we talk about a hard drive, the disk is divided into concentric circles called as tracks. They range from the spindle to the outermost track. The spindle is the axis along which the disk rotates. So you have tracks, and each track has a 512 bytes of an addressable area called as sector. The disk in general has a sector size of 512 bytes. New generation disks are now available in market where the sector size is 4K, in other words 4096 bytes. Just to quickly find out what is the case here, I am saying fdisk -L and I can see all our disks are with the sector size of 512 bytes. Remember, these SDB to SDE are the LUNs that we have got from the NetApp filer using ASMCA protocol, and on top of these LUNs we created the ASM disk 1 till 4. So SDB1 is ASM disk 1, SDC1 is ASM disk 2, SDD1 is ASM disk 3, and SDE1 is ASM disk 4. So it describes the physical attributes of a disk called as the disk geometry, and in our disk geometry we have a sector of 512 bytes. Now consider a case that I am working against ASM where the LUNs provided to me are coming from a newer generation disk where the sector size is of 4K, and if I issue a command to create a disk group, Oracle's assumption would be that those disks are general purpose 512 bytes of a sector size disk, and which will not work in the create disk group command. So categorically you will have to override in that case, saying that the sector size of this disk is 4K. The sector size attribute is an optional parameter used with create disk group command, which specifies the size of one disk sector, which in general is 512 bytes, but newer generation disk will have, they already have a sector size of 4KB. So while creating a disk group with such a disk, you may have to override the default sector size by using the sector size attribute of create disk group command, mentioning it as either 4K or mention it into bytes as 4096 bytes. In database as well, this is applicable for ASM. For database, the only file that depends on the physical disk block size, that is nothing but the sector size, is redo logs. Redo logs, remember, they are written in operating system physical disk block size and not in Oracle units or Oracle block size. So on for such databases, if you are trying to keep your redo log on a disk where the sector size is 4K, or if you are trying to keep your redo log on a disk group where the sector size of those disks is 4K, then you must categorically in the alter database add log file command must mention block size as 4KB. All other files are unaffected. So other files don't care about what is your physical disk block size, but redo logs for databases and ASM disk group, while create disk group command is applied, these are the only two things where you have to categorically override the physical sector size if you are using a non-standard sector size other than 512 bytes. In our case, the sector size is 512 bytes. The most important ones, however, are the compatibility attributes. There are three compatibility attributes called as compatible.rdbms, compatible.asm, and compatible.advm. So these three attributes along with their default values are mentioned here. The compatible.rdbms parameter for a disk group, remember it's an attribute of a disk group. So if the disk group attribute compatible.rdbms says that the value is 11.2.0, then it has some implication, which is it specifies the minimum software version required for the database instance to be able to use this disk group. So what should be the version of your database to be able to use the given disk group is what you mention using compatible.rdbms. The default value for this parameter is 10.1, which means if my database is 10G release 1, 10G release 2, 11G release 1, 11G release 2, any of those databases can make use of this disk group. That's why the default parameter, default value for compatible.rdbms attribute is 10.1. So my ASM software may be 11G release 2, but my database software can still be of the version 10.1, and my database would still not have any problem communicating with the ASM because of compatible.rdbms attribute of the disk group is set to 10.1 by default. However, there are certain limitations of this one that we will compare what is the relative dependency between these compatibility attributes. Next one is compatible.asm, which specifies the minimum software version required for ASM instance to mount this disk group. So what should be the version of your ASM software to be able to mount a given disk group? That is because from version 10.1 to 10.2 to 11.1 to 11.2, the ASM metadata elements are different. So if you check what metadata ASM used to manage in 10.1, it's different than what it manages in 10.2, and it's different than what it manages in 11.1, and is different than what it manages in 11.2. The metadata elements are changing. That's why it is significant to categorically identify what type of metadata is to be written on a given disk group. If you select the compatibility value as higher, the highest one is 11.2, you will get all the new features in your ASM. If you select the older value, the older metadata never used to have those many elements. So features wise, you will get less ASM features, and the advantage, however, there is you can use a lower version of ASM software to mount this disk group. So it's not that you will need only 11.2 software. So when I look at our values, compatible.asm says 11.2. Now question is, if compatible.rdbms it can keep to a lower value, why could it not keep it to the same lower value? Although possible values are 10.1, 10.2, 11.1, 11.2, then why by default it selected compatible.asm as 11.2? The reason is, if compatible.asm would have been of a lower value, say 10.2, for example, in 10G release 2, you cannot keep voting disk and OCR onto ASM. So compatible must be anyways higher so that your OCR and voting disk can be kept onto a ASM disk group. So compatible.asm is 11.2, but compatible.rdbms is still by default 10.1. So my OCR and voting disk, because of this line and this compatibility, can be stored on a disk group. And because of this line, the same disk group can be used by 10G release 1, 10G release 2, 11G release 1 or 11G release 2 database software. Somewhat relatively easy as of today's version is compatible.advm, which allows the creation of ASM volumes. Within a disk group, you can further create logical disks called as ASM volumes. This feature was added to ASM in 10.2. So there is no question of setting this value to anything lower than 10.2. Sorry, 11.2 I mean. So you can set it to 11.2 or higher. Now there is no higher thing possible as of now, right? There is no software that is beyond 11.2. The highest version publicly available today is 11.2. Now this will only be sensible when I go to release 12c databases, because lower value is anyways not possible for this parameter. That's why there is no default value mentioned. The only value that is applicable is 11.2 as of now, and maybe a couple of months down the line, that time when 12c database is there, probably it will make some sense. Next one is access underscore control dot enabled. Default value is false. It allows you to create ACLs, access control lists. Default is false. Now question is, what is the significance of ACL? You might be working in an environment where multiple users have access to ASM disk group or ASM command line utility. By default, we are not going for separation of duties, by the way. In case of separation of duties, consider that I have implemented ASM as Aura Grid and DB as Oracle user. Now I have three databases called as dev, test and QA on the same server using my disk group huge data. Now by default, Oracle does not distinguish between any user other than Aura Grid. So anybody who has got an access for Aura Grid, he is the super user. So all the permissions are by default granted to that user, which means if I have three different DBAs in my environment, Tom, Dick and Harry, respectively for dev, test and QA database, that means there is no distinction at an ASM level. Anybody can access anybody's files. Now to be able to distinguish it, you may want to enable access control list, in which case Tom can only access files belonging to dev database, although they are also being stored on the same disk group huge data, where the database test also stores its file. So to avoid those generic permissions where each user can access anybody's file, you need to enable access control lists, ACLs, which by default is false, which means no ACLs are enabled by default. So when I go to and query from $asm underscore file, not files, file, you can see by default the permissions are RW. Means pretty much any user can do anything as long as he has an access to ASM command prompt or to an ASM environment. There is no distinction. It may be Tom, Dick or Harry, they all are considered as peer. If you however want to implement a separation of duties, then in that case you may want to enable access control lists. Otherwise these permissions are pretty generic, meaning everybody can read and write wherever. Next one is access underscore control dot umask. This is what would be the default permissions applied to a file and is only meaningful when ACLs are enabled. If ACLs are not enabled, that umask is also meaningless. Then a pretty generic umask is applied, which is RW. But even when I have applied RW, The enforcement will only come when access control lists are enabled. Otherwise, those permissions are quite generic, meaning 0, 2, 6 in a triplicate for the owner, group, and others, which is quite similar to UMask setting at a Unix level. So this UMask is for the file permissions for all the files that will be created on your ASM disk group, and is only meaningful by default. The UMask is generic. It allows read write, read write, read write for owner, group members, and others. So the only sense when this UMask will be effective or can be enforced is when you enable the access control list. Otherwise, Aura Grid user is the only user, and Aura Grid can pretty much access any files. Next is cell.smart_scan capable. This feature is for Exadata machine. Now Exadata is a database appliance which is designed as one integrated machine having everything. So you will get one rack that contains multiple computing nodes, CPUs, memory modules, storage, SAN switch, network switches in one single rack. Those machines use a different type of a disk storage technology called as cell data structure, which can cache frequently required data in a faster disk storage like SSDs, flash disks, instead of storing that data onto a regular hard drives. Now cell smart scan capable feature by default is false, and you cannot make it true. You may be able to make it true, but it will not serve any purpose because yours is not a Exadata machine. Exadata is a database appliance. Now what an database appliance is, how is that machine different? You can go to oracle.com on the Avengers. The Avengers is where you can find that Exadata machine's description. You know, there's a recent movie that was there, Iron Man 3. They do a lot of advertising of Oracle. See here, the Avengers. What I like about this, I mean, I like the machine minus the cost, but they have made technology quite simple, at least from the naming perspective. These machines are available in three configurations called as quarter, half, and full. So that way it's very simple. You will not understand that. Ask Nachiket what is that. They are available in three configurations. So which is an Exadata machine. It's one hell of a machine considering the configuration. Everything in one single box. Quite an you have an interesting video here. Do visit and find out what is Exadata machine. It's quite interesting. So this particular attribute of a disk group is only applicable for Exadata machines, not for a general purpose machine. You can query these attributes from the dynamic performance view $ASM attribute, or you can also use ASMCMD command ls-attr. So you can see those attributes. Now an important discussion about what is the link between the various compatibility attributes available within ASM. You don't have to remember this. You can always refer to Metalink latest chart which defines these compatibility attributes and their dependencies. This group compatibility attribute can be set using create this group command, or at a later stage you can also alter it using alter this group command. Remember, like a compatible attribute of your database, the values once increased cannot be decreased back. So starting from 10G, the compatible attribute can only monotonously grow. Once it has adopted a new value, then you cannot reduce it to an earlier version. No. Values can only be advanced and the settings are irreversible. So if my value is 10.1, that's fine. But the moment I make it 10.2, I cannot now make it 10.1. Although I can always change it to 11.1 or 11.2. So only one way higher side values can be assigned to any of those compatibility related attributes. They cannot be lowered once it has been changed. Compatible.rdbms must be less or equal to compatible.asm. This is the dependency. So as part of that compatibility value for ASM, RDBMS and lately ADVM, this is the dependency. If your compatible.asm is 10.1, then RDBMS has to be either lower or same. There is no question of ADVM because ADVM only came in picture in 11.2. So ASM instance can be 10.1 or any higher version. So higher is okay. RDBMS can either be 10.1 or any higher version is okay. If my compatible.asm is 11.1, compatible.rdbms can be lower value, I told you. Then ASM can be of the version 11.1 or higher. RDBMS can be 10.1 or higher. If my compatible.asm is 11.2 and if my compatible.rdbms is 11.1, then I optionally get a choice to enable ADVM compatibility for a disk group. If compatible for .advm is 11.2, only then you will be able to create volumes inside a disk group. Then my ASM instance software can be of version 11.2 or higher, and RDBMS software can be 11.1 or higher. If all of them are 11.2, which is what you should be doing in general life, then ASM can be of 11.2 or higher, RDBMS can be 11.2 or higher. Although mixed mode running is possible, meaning ASM of higher version, RDBMS of lower version is possible. You can alter the disk group compatibility attribute by saying alter disk group name set attribute followed by name of the attribute in single quote equal to followed by value in single quote. And then what was introduced in what version? In 11G. In 10G, there was only one fixed AU, that is 1 MB. Starting from 11G release 1, Oracle introduced variable size AU, which can be selected by the user. Now starting from 11G release 1, AU size can be selected by user in the range of 1 MB to 64 MB. For this, compatible.asm should be 11.1. In our case, compatible.asm is 11.2. To be able to use variable size AU, your database must be also 11.1. If none of those softwares are 11.1, they are below, then fixed AU of 1 MB is applicable to you. Then you cannot select a AU size. Attributes were introduced in 11.1. Prior to 11.1, there was no view called as $ASM attribute. So attribute feature itself was introduced in 11G release 1. Where are these maintained, by the way? Where is the AU size, attributes, all these data related to them maintained in ASM metadata? That's why I said the metadata itself, the elements in the metadata have changed significantly from the point ASM was introduced in 10G release 1 till what it is now in 11G release 2. So the feature where one can query ASM attribute from the metadata was itself added in 11G release 1. Fast mirror resync, that is nothing but the disk repair time attribute, was added in 11G R1. Exadata storage support was added in 11.1070. 11G release 1 means 11.1060, 11.1070. But Exadata feature was especially added in a patch set 11.1070. Variable size extents, I told you, first 20,000 data extents are of 1 AU, means 1 MB. Next 20,000 extents are of 8 MB, and remaining beyond that they are of 64 MB. This feature was added in 11G R1. Preferred read failure groups requires a discussion. This comes only for X or long distance clusters. Called as metro clusters or stretched clusters. I have a cluster which is a metro cluster. Where one node is in Hadapsar, another is in Gahunje, that stadium, near that stadium. So the distance between these two nodes is, they are couple of kilometers apart from each other. Now consider such a stretch cluster implementation where I have node 1 running here, node 2 running here, a typical metro cluster. I have its local SAN in this data center. I have one SAN in this data center. However, there exists a crisscross connectivity. So anyways, I can access those SAN, local SAN from my data center in Hadapsar, remote SAN from my data center in Gahunje. So I can access it. I am running ASM instance 1 here, ASM instance 2 here. I have provided from this SAN say couple of LUNs. I have provided couple of LUNs from this SAN as well. Then I defined a disk group data with two failure groups, FG1 and FG2. From these 6 LUNs, I created a disk group which is accessible from both the places. This disk I placed in FG1. This disk I placed in FG2. Clear? If I do not categorically restrict an ASM instance, my ASM instance can write either to these 3 LUNs or in a redundant manner to these 3 LUNs, isn't it? So it can write to any, it can read from and write to any of the disks. So this is FG1, this is FG2, assuming a normal redundancy. Now tell me from the distance perspective, which would be wise? ASM1 instance accessing this disk would be faster, or ASM instance 1 accessing this disk would be faster? Which one would be faster? LUNs, they can be accessed from anywhere. So IO would be efficient from the LUNs coming from the local SAN or from a remote SAN. So if I read, if this ASM instance reads from these LUNs, it would be a faster IO than this ASM reading from these LUNs. Clear? Your preferred read failure group init aura parameter defines affinity of a failure group with a ASM instance. So I would write in my P file, SP file for ASM instance, I would say plus ASM1 preferred read failure group is FG1, and for ASM2 I would say preferred read failure group is FG2. This is called as mentioning the FG affinity with your ASM instance. So whenever ASM1 has to read or write, it would read it from FG1. When ASM instance 2 has to do the same thing, it would do it from FG2, because the LUNs coming from FG1 are local to the data center where ASM1 is running, and the LUNs coming for FG2 are coming from the local data center where ASM2 is running. So this feature of binding ASM's affinity with the failure group was itself introduced in 11G release 1 and makes sense only when we are talking about stretched clusters or metro clusters. If you have only one SAN, it's in the same data center where my node 1 and node 2 is running, then binding the affinity of your ASM instance has no meaning or will not provide you any performance improvement per se, until we go for that scenario that I have described you in the diagram. Intelligent data placement is a user's choice where he would like to keep the data in the region where IO is fast or in the region where IO is slow. This feature of user selecting a region from a disk was introduced in 11G release 2 as part of IDP, intelligent data placement. I told you earlier, if I have a disk platter, so you know how bad I am now. Doing an IO from the outer track is always faster than doing an IO against the inner track. That is because inner tracks would have less number of sectors per track compared to the number of sectors available on outer track. So if I store my file on the outer track, IO would be faster. So user has a choice starting from 11G release 2 that when you keep your files on a ASM disk group, you can mention categorically, should it be placed in a hot region or should it be placed in a cold region. A hot region is made up of outer tracks. A cold region is made up of inner tracks. So you can, depending on what IO characteristics you expect from a given file, you can keep some IO sensitive files in the hot region. default is cold for all. By default, if you don't mention, then all files, the disk is filled from innermost track towards outermost track. So the default selection is cold. So if you see how ASM fills in those disks are filled in inward out. So from the innermost track, it will start putting your files until all the tracks are occupied in a given disk group. But if you think otherwise, if you think my file is too IO sensitive, it experiences high IO at any given point in time, then probably you might want to keep such a file on the outer tracks, in other words, in the hot region of a disk group. This IDP feature itself was introduced in 11G-R2. Keeping OCR and voting disk on a disk group was introduced in 11G release 2. That's why compatible.asm has to be 11.2. That's why in our case it's 11.2. It has nothing to do with RDBMS. That's why categorically it has been marked as NA. Selectable sector sizes feature was added in 11.2. Meaning if you use a disk of 4 KB sector size and your software version is 11.1, you cannot use those disks. So you will be only able to use those disks of 4 KB sector size starting from 11G release 2. Remember, if I am creating a disk group, I cannot add a mix and match of disks. I cannot add 2 disks of 512 KB sector size and other 2 disks of 4 KB sector size. Those disks are to be all of 512 or all of 4 KB. Because that attribute is not for a disk, it is for a disk group. So if a sector size has to be selected, it has to be selected for all the disks belonging to a disk group. The ability to keep a ASM's SP file on a disk group was introduced in 11G-R2. Access control list feature was introduced in 11G-R2. The ability to create volumes inside a ASM disk group was introduced in 11.2, and that's why compatible.adbm only matters in this case, not otherwise. So this is how version wise how Oracle has improved over a period of time. I have already done a discussion on support for 4 KB sector size disk drive. I'm not going to reiterate it again. I told you earlier the only file that has some implication is the redo log. So while creating, you must mention the block size. If your redo logs are going on a disk group with a 4 KB sector size, you must mention the block size attribute. Otherwise the default assumption is 512 bytes. Using a sector size clause, create disk group this with normal redundancy, fail group these 4 disks, the second fail group these 4 disks, attribute sector size 4096. Clear? You can query the dynamic performance view $ASM disk group $ASM underscore disk group underscore stat, which will give you the performance statistics of a given disk group. You can use lsdsk command. We have seen this earlier with options as -t -k. We have already seen this, how to extend an existing disk group by adding a new disk, how to shrink a disk group by dropping a disk. I also explained while adding, you can add a disk by deferring the rebalancing by setting the rebalancing power to 0, which means while adding, don't do a rebalancing immediately. Defer it for off-peak hours. And then, let's say I added a disk. Now I want to do the rebalancing, then I can always say during off peak hours, I would say alter disk group data rebalance. It came out quite early. There is no rebalancing required. Default is 1. So you may have to categorically add a disk by setting rebalance power as 0. I already explained $ASM operation and the equivalent LSOP command. Adding and dropping in the same command. That's what we have recorded earlier as well. This is good. If you think you have accidentally dropped a disk, undropping a disk is possible. But there is a time tolerance within which you need to act upon. When you remove a disk, the command returns to SQL prompt immediately. That doesn't mean the disk has been removed. Oracle automatically triggers rebalancing. So whatever data is there on the disk that you have recently removed, Oracle migrates all those data extents from that disk to the remaining disks. Now this might take some time depending on how much data was there on that particular disk. So depending on that, it might take some time. Now within the rebalance operation is finished, within that time, if you think otherwise, you can always undrop a disk. So you can say alter disk group name undrop disks. So it will undo your dropping operation. But if you are slow in typing and by that time the rebalancing operation has finished, then you don't expect it to add it back. So you can say alter disk group data undrop disks. You can do it for multiple disk group in one shot by saying alter disk group dg1 dg2 undrop disks. You can say alter disk group all undrop disks. Mounting and dismounting a disk group we have seen. You can say alter disk group name mount, after which you can also say restricted or normal. Default is normal. Force or no force. That force or no force is for whether or not it can be mounted in general, or shall I do a force mount even if a couple of members are missing. Obviously this applies only for disk group which has some redundancy and quorum disk defined. More on that at a later stage. You can see who is using your ASM currently by querying $ASM client or ASM CMD command lsct. To drop a disk group, you can say drop disk group name force if the disk group is not mounted, including contents if the disk group is not empty. In an abrupt shutdown of an ASM instance, like an abrupt shutdown of a machine, next time when you power on your machine performs a file system consistency check. On the similar lines, you can also force a consistency check for a disk group to see that there are no inconsistencies amongst the metadata and the data that you have stored on the disk. It's quite synonymous to FSCK. FSCK is a file system consistency check command in case of Unix and scan disk in case of Windows. So you can say alter disk group name check. It will only report inconsistencies if any. If you say check repair, then it will not only report it, it will also try to mitigate those inconsistencies. We already talked about fast mirror resync operation, which is disk repair time of 3.6 hours. Was introduced in 11G R1. So what would happen when a disk goes offline? Nothing would happen until 3.6 hours. After that, ASM will automatically start fast mirror resync operation. I also explained you preferred read failure groups for extended clusters, where FG1 comprises of LUNs coming from a local SAN, FG2 comprises of LUNs coming from a remote SAN. Then it makes sense to add a parameter so that my ASM instance can read from a given failure group instead of reading from the remote failure group. You can see the ASM disk statistics by querying $ASM disk IO stat. This is to find out if you are hitting any IO bottlenecks. You can also use the equivalent command lsdsk -- statistics. It will tell you how many read writes have happened on a given ASM disk. A database equivalent of this one is $file stat. $file stat will show you file wise IO statistics for each database. This is to check which files are hot, which are experiencing IO waits, so as you can tune the IO part of it. Especially you would be interested in looking AVG IO TIM column. That AVG IO TIM column should consistently report a value as 0, which means there is no IO wait. You can query $ASM underscore disk underscore IO stat from SQL Star Plus. It will provide you reads, writes, how many bytes you have written, how many times the operation has happened. This is to tune your IO path. And AVG IO time should consistently report you value as 0. That means there is no IO bottleneck. So if your database is performing slowly, the first thing you should look into, is there any IO bottleneck? I can see there is a IO bottleneck for file 1, which is system data file. So that's for this particular session. So I have talked about how to create a disk group, how to alter a disk group, what are ASM disk group attributes, the discussion on compatibility, and version wise what all features were introduced into ASM. In the next session I would be talking about file naming convention, which is OMF, and ADVM feature along with ACFS and snapshots.